But yeah, I'm here to talk to you about why you shouldn't be scared about rebooting and sort of trying to encourage everybody to think a little bit more, why are we doing all of this immutable Linux stuff and what's wrong with what have we been doing for the last 30, 40 years. And a little about myself, I'm a distribution architect working at SUSE in the Linux department. Before that, I was one of you. I was a customer of SUSE and Novell before that, then working at SUSE in QA, breaking things. I'm really good at breaking things still. Then fixing them, releasing them, and yeah, these days also thinking about how we're going to build things in the future. So yeah, doing this for a very long time, and even created my own immutable system, which I will talk about a little more later. The agenda really then is to start you off with telling you how everything that we are currently selling you that is wonderful and you are paying lots of money for is totally and utterly broken. And how there is a lot of really scary stuff going on under the hood, and yeah, why that isn't necessarily a great thing. And then actually discussing how I think most of you already know a lot of those issues, if not actually in detail, at least implicitly, and discussing some of the strategies and procedures that you all follow when you are running traditional Linux, and then kind of showing how immutability is really just the next step in that journey, to really kind of take what you are all doing as sysadmins and as network managers and actually turn that into an operating model rather than something you have to do extra on top of our product. So, starting off with, traditional Linux is broken. If you think about it, it actually makes a lot of sense. You know, when we talk about Linux, we talk about how wonderfully flexible and adaptable and adjustable it is. But that typically means most of our Linux products are very much like Swiss Army knives. You know, lots of tiny little tools that may not actually be the best tool for doing the job, but it's the tool we give you and it's there and you can pick which one. But that means, you know, it ends up getting this sort of thicker and thicker, ginormous Swiss Army knife with, you know, lots of things that could possibly go wrong, lots of things that could break. And that's just when sort of individually thinking of the tools operating on their own and the software operating on its own. That's not how Linux works. This is complex software with thousands of interacting, moving parts. You know, we talk about OpenSUSE Tumbleweed as this scary rolling release with, you know, 15,000 plus different source packages as part of the code base. And it's true, it's 15,000 packages constantly moving every day. Well, SLEAF 15 SP6 has 43,000 source packages, because not only do we actually have the package you are running on your system, we have the source packages for every variation of every maintenance update we have ever done, ever. And we build all of those still, and we ship all of those still, and those are all sitting in the repository, and we've got to potentially handle every possible combination that you could be possibly deploying of any one of those. It's a potential matrix of absolute insanity. It is less actual packages, so we do, you know, it's not, there's a lot of duplication in there that makes things a little bit easier. But that still means, for example, when you're running Zypper on your machine, you know, Zypper is having to handle all of the possible dependency resolution of all of those different combinations, and that's why a Zypper refresh takes so long sometimes on Sleek, because it's churning through this metadata, figuring this stuff out, caching it, etc. And each one of these numbers out there, that's source RPMs. We can easily produce 2, 3, 4, 5, 1,000 different binary RPMs out of a single source RPM. So I gave up trying to count the actual number of binary packages we have in the distros. It's a lot. And I've been working a lot lately on what is now known as SUSE Linux Framework 1, or before that was ALP. And some of the ideas we were sort of figuring out of how to model that is, you know, how to kind of tune things up like we're thinking for those products is like, let's stop thinking of these things as individual packages and start grouping them together. Maybe that'll make the whole thing more simple to understand. And this is the simplest diagram we came up with. You know, and yeah, just to kind of show the different components you've got bumping around with each other, and this is not going to show, but that's fine. Yeah, so, you know, yeah, there's a core down there, and then there's extra stuff for the kernel, and then that's pulling stuff from, yeah, hardware access, and Python's probably just linking into everything. Everything ends up talking to everything all the time. This is what we are doing when we are building Linux distributions. That's fine, but it is an incredibly complicated, constantly moving stack, even when we are dealing with stable enterprise releases. And when we've done all of that, we've designed everything, we've picked which packages are going in the repository, you're then installing those on your servers. And every single binary RPM is requiring at least one other RPM, typically speaking, or required by at least one other RPM, and can quite easily require any number more in addition. And there are lots of cases like this tree here, which hopefully you can read, where, yes, package OpenSSL3 requires OpenSSL, which requires package OpenSSL3, which requires OpenSSL, and the thing just loops around forever. Now, this is something that, in practical terms, we make invisible to you. Zipper discovers it's looping around this dependency tree, breaks the tree, installs what it has to install. But when we start talking later about what actually happens when you install an RPM, keep this in mind, because this, depending on where Zipper decides to break these kind of loops, which one is it installing first? Which one is it installing last? What actual package is the last thing to touch your system when it's looping through installing OpenSSL and 3 and core utils, etc. Assuming your system has then installed something perfectly normally and everything is running, think about patching a system with a running process. You update some library on your running system, your process is running on top of it, perfectly happy and fine, and then suddenly the function that it's calling from the library underneath might behave differently. Might not, should not. We have lots of processes where we try our best to never ship a broken or different ABI in a library, but that's processes, that's humans. There's nothing technically stopping a library completely changing how it behaves while your system is running. There's no guarantee that library updates are smooth, sane, and most of the time we're also just trusting what upstreams tell us as well. They say that updating libse Linux 1 is never going to break library functionality. We hope that to be true. We test it, but we're not going to be able to test every single function all the time in flight while you're running everything. There's a lot of sort of wish and a prayer that goes on with libraries being updated on systems. And then the same again when you think about binaries being installed in a system. You have a running process, it's doing stuff, it's your Apache server giving out websites to users, and you update it with a new version of Apache. Do you always restart your Apache server when you've updated it with the latest patch? Zipper tells you to. Every single time that you update a service with a running process, Zipper will give you this error message. And I think nobody ever does it. I know I don't. But Zipper PS exists there to list every single process that it replaced the binary for while it's running. And almost all of us just ignore it and keep the system running. But does that mean your system's secure? Probably not. You're still running the old service with whatever CVE that it had until the next time that service starts, or depending on how the service is designed, maybe the next time it spawns a child process of itself. But you don't necessarily know the system is secure at that point. You don't know if it's consistent. And you won't until the next time you restart everything. And we talk about RPMs and packages in general on Linux as if they are Lego bricks. Tiny little bits of software, like zip files on Windows, where it's all pre-built by SUSE and everything is predefined and reproducible, and we're just putting files on your hard disk. But they're not. Every single RPM is an executable in its own right. And they can run whatever the heck they want. And they're running as root. Live on your system while you're doing stuff. So there is no limit to what they can do. And perfect examples of what they have to do their job, to do the upgrades that you want, can quite easily be deleting files anywhere on the file system that it feels like, Changing your configuration, which is something we do tons of, because every time there's a new version of a piece of software, it's got a new configuration layout. We've got to figure out how to get your old configuration in that new layout. Injecting files that aren't actually in the source code, normally around the content of configuration, adding extra files to your disk. Restarting systemd services. Every time we introduce a new systemd service, or remove it, got to restart what was already running. And every time we introduce a new one, we've got to do a daemon reload and restart systemd. Luckily, that isn't disruptive most of the time, but it might be. And these are all running as root every time you do a zipper patch or a zipper update. It's a miracle that any of our systems work, to be honest. And when you think of this is an example actually from the spec file, from an RPM, from MariaDB, and it's too much to read up here, but to give you an idea of some of the scripts that are happening every time you are updating MariaDB, it's going into your etc and messing around with your configurations. It's writing triggers into var, so next time MariaDB starts, it triggers a database update. And it also goes around and trashes out markers that might have been left there by MySQL. So I hope you aren't sharing your var partition with two different systems, one with MariaDB and MySQL. Because if that happens, it's just going to randomly delete the markers that might have been left there for your database upgrade of your MySQL that might also be on the same machine. So it's perfectly valid thought when you're thinking about a single machine accessing a single disk, but you put this in a real world with shared storage, and suddenly this becomes a problem. So when it comes to package installations, the only thing I can really guarantee is they're not necessarily going to be consistent. We don't know exactly what is on your disk at any one time. We don't know exactly which order we're going to install those RPMs in. If we're talking about one of those dependency loops, one package could easily be happening before the other, which means different files can be on the disk. Different data can be on the disk. That can be interpreted by the script to then trigger different behavior there. Different services could be running. Literally, and all of this stuff could be changing how the script actually works when it runs on any RPM install you ever do. The worst example that I can think of in any SUSE code base was written by myself. If you've installed Podman up to, I think, SP5, I'm pretty sure we dropped this in SP6. I hope we dropped it in SP5, to be honest. We had a perfectly valid feature request where, we're using BTRFS. We know our customers are using BTRFS for their var location where their containers are stored. So we had customers that wanted to make sure they were using BTRFS for their containers on var. So every time you install libcontainers common on older SLE machines, it will go and see var and check, is it mounted as BTRFS? If yes, it's going to go in and mess with your configuration and use BTRFS as a storage driver. Doesn't matter if you have containers already on there that aren't BTRFS, it's going to do that. So any existing containers suddenly don't necessarily work. If var is normally NFS, but it isn't NFS because you took it off the storage while you were doing this upgrade, this suddenly changes your config, and then you rejoin your var partition, and all your containers don't work. It just goes horribly wrong in so many real-world cases. But it was exactly what we were asked to do. Feature complete, all fine, but it was such a bad idea. I'm really sorry. Like I say, it's gone now. We don't do this anymore. Another example that actually hits me on a semi-daily basis, because we use a tool called GoCD for some of our build tooling on the OpenSUSE side of things. And it's a Java application, doing CI/CD, fancy little Java agents running on a server. There's a server part and an agents part, and a common wrapper that launches either the server or the agents. All of this is running with headless Java, any version before 13, any version below 17. Every single time Java gets updated on that SLE 15 server, every single one of my pipelines breaks. And the reason is, every time we update Java, the Java version changes. We've just updated it. That means the Java home environmental variable needs to change to point to the new Java location. But all those agents loaded with the old Java home, and that Java home is currently in memory while they're loaded. So suddenly they can't get to their Java anymore because it's gone. And they don't know to reload their Java home because they loaded with the other. Like, why would they? There's no reason to do so. So every single Java pipeline I have there is just dead and look, yeah, can't find Java, can't do anything. So I have no hope in hell apart from going into the machine, stopping every single systemd service related to this and restarting all of them again. So every time we update Java, it breaks everything actually using it. And this isn't a bug. Like, you know, the package is doing exactly what it should be doing. It should be defining a new Java home. But it's also not a bug that, you know, a system using something using the Java home shouldn't expect it to randomly change while it's running. You know, there's no magical tool to fix this. Everybody is doing everything right, and still, you know, the world is horrible, everything is bad. And you know, unplanned outages are a fact of life. We do our best at SUSE to mitigate a lot of this. You know, we have our maintenance update process where we take a ton of care with every RPM coming out of the maintenance process to not be doing major library changes so the functions aren't changing there, not to mess around with the binaries too much unless we really have to. But you know, you're still getting that zipper PS message telling you to restart all the services, and everyone's still ignoring them. And those RPM scripts are still running every single time, including the one redefining Java home, and including the one messing around with your MySQL config. And live patches, of course, again, exist to mitigate some of this by you know, dramatically shrinking how much we're messing around with. You know, we're not changing the whole library. We're just changing a function in the library or a function in the kernel. So, you know, but even that, you know, we take a ton of care to make sure that we're hijacking the current processes running through that live patch function when we're patching it. Doesn't mean it's always going to work. And even when it does work right, it's still being delivered as an RPM. That RPM is still running a script. I have had wonderful cases of, again, I wrote it, live patch scripting doing stuff that it shouldn't have been doing. We can't think of every possible variation of what could really be happening at runtime while your system is running. You know, there's just too many different things that can change. Both things we can control, and then of course everything that you can control. It's really impossible to take into account every possibility. And this chaos, I think, I mean, there's been enough chuckling as I've been talking about this, is something that we all kind of know anyway. Even if you don't necessarily know the details, the reality is seen every time you do an update. You know it's not necessarily always going to be perfect. You're always prepared for there being some kind of outage. That's why you take care on these things. This is why more and more these days, everyone is deploying everything as a VM or as a single-purpose machine. If you have less stuff in your instance, you have less stuff to go wrong when you update it. You know, you minimize what you have installed. Again, less stuff there, less stuff to go wrong. You know, the mantra of never touch a running system is a good one. I mean, that does lead to the downside of delaying and ignoring patching, but you know, if your system's running, that's better than a broken system because you are updating it. And then, of course, adding things like redundant instances. So, you know, if your one instance of, well, GoCD, for example, breaks, that doesn't matter if everyone is being able to fall back to something else. And leaning more and more on automation rather than micromanaging. And yeah, I kind of spoke about all of this while I was going through it, but yeah. You know, when you're talking about single-purpose systems, you know, there is less stuff to break. There are less components to update, so you have less updates, you have less reason to touch it in the first place. Also, you make that dependency tree and those crazy graphs of ours way, way simpler. You know, if the machine is just doing one thing, you pretty much just need the kernel, you pretty much just need systemd, and you need that one thing. Like, that's a ton simpler than all the possibilities of everything else that could be going on. It's easier to monitor, it's easier to debug, and then it's easier to repair when it does go wrong. It does have a little bit of downsides when you start thinking this way and you do everything as single-purpose installs. You know, you end up with more installations to play with. That leads to you wanting to do more automation. We talk about that later. And, it takes a ton of effort. If you're starting with a traditional Linux installation, getting that traditional Linux installation down to something tiny is a ton of work. And a ton of work to maintain, because it keeps on wanting to try and grow as as it finds more packages to try and pull through. It is not easy to keep something small, start making something small and keep it that way. And repairing stuff at scale with lots of instances gets really, really complicated. You don't want to be running around manually patching dozens and dozens of machines. Never touch a running system. When I was a sysadmin, I always said this, especially on a Friday. And it's true. A working system can't break if there's no changes on it. If it started and it's working, it's probably going to stay working until something changes somewhere. You then take care with things like maintenance windows. So, the only time it's likely to break is the time when you have the staff around for you to fix it. It means you've got the engineers around to help fix it when you can. And, therefore makes the outage as small and as little of an impact on your business as possible. But again, it's not all sunshine and roses. You don't want to be running an insecure system, and an unpatched system is an insecure one. And like we talked about earlier, just because you've patched it, if you haven't restarted everything, it's still insecure. And we're not in this wonderful world where we can afford to turn the systems down at nice, friendly times for sysadmins. The customer-friendly best time is normally like the least friendly time for a sysadmin. You remember 2 a.m. wake-up calls were never fun. Redundancy, automation, we're seeing this trend in the market all over the place. More use of clustering, more use of Kubernetes, more use of Salt and Ansible and all that stuff. It's part of this same old story. You've got more instances, you're making them trimmer, you're trying to maintain them better. Therefore, you automate more and more and more. Keep the impact of outages smaller so you can roll out all those fixes quicker, have a shorter time to recovery, and hopefully less humans waking up at 2 in the morning to go fix your machines when it all goes horribly wrong. But when your infrastructure gets really complicated with all this Kubernetes stuff, you've suddenly introduced a whole bunch of new ways for your system to break. So it's not always a free ride. And sort of this is the mindset that we at SUSE started thinking about when we started talking about Immutable Linux. We weren't just trying to reinvent the wheel for the sake of reinventing it. We want a Linux operating system that should just work. You deploy it, you set it, you forget it, and it takes care of itself as much as it can. It shouldn't need your complex business and IT department policies, best practices, patch windows, etc., to live with on a daily basis. It should be taking care of itself as much as humanly or computerly possible. And it should be built in a way where all these best practices, all those things I was just talking about, are the standard way for it to be used, the way it's designed to be done, rather than something we've all bolted on retroactively to our Swiss Army knife traditional Linux distros. And it's not going to be perfect, but all the rough edges we mitigate as much as we can. So, optimized for single-purpose installations. You deploy Linux, it does just one job. Therefore, you have a minimum amount of services in the installation. You have an update mechanism that guarantees zero impact to the running system. No scripts running around doing stuff that they shouldn't, no random ordering with packages, no variation. The running system never gets touched. Even then, potentially in our case still using RPMs behind, you still potentially might have some issue on the next boot. So you then take self-healing over manual repair. Have the system detect what went wrong, have the system recover from that, so you're not having to send a maintenance engineer out to fix everything. That should make it really, really easy to use all of this stuff at scale, and should make it really easy to then automate and orchestrate this at scale with whatever tool you want to use. So it shouldn't need manual maintenance. It can definitely support manual maintenance if you want to play with it, but it shouldn't need manual interaction to keep the system running, to start it up. It shouldn't need tools like YAST to get the thing up and running and the like. While it's operating, it should never be in sort of an inconsistent and unknown state. You shouldn't be in that situation like you get with traditional Linux of, I've patched it, but did I restart all those services? Do I know that I'm actually covered with all those CVEs? Is everything in a perfect state or not? That isn't the dream we're trying to chase here. And it shouldn't necessarily require that complex orchestration. It's nice to have and nice to integrate with, but you should, if you're running in any old environment from, edge to data centers to whatever, you might not make sense to suddenly have giant Kubernetes or giant Harvester clusters to deploy all of this stuff. So definitely support it, but not require it. And in SUSE, we already have that family. We have SUSE Linux Enterprise Micro, which is the enterprise expression of everything I've just been talking about. It's the best enterprise server, in my view, we have out there today. It's a wonderful container host, it's a wonderful VM host. On the edge, it's perfect for whatever single use case you have, however you want to deploy it. MicroOS then takes that same thing, the same concept, and puts that out in the community at wild, at speed, doing all of this stuff with the Tumbleweed code base. Rolling release, moving fast, latest of everything. But because of all this stuff we've just been talking about, a lot of the kind of fear of rolling releases and moving fast and being close to upstream suddenly kind of go away. The time to resolution on an issue when, if the machine automatically patches itself, automatically rolls back, automatically updates itself again, who cares if it's half a day behind what's latest upstream when it's going to be fine tomorrow anyway. And then the newest member to this family, my baby, OpenSUSE Aeon, where I've taken all of this and decided to turn it into a desktop as well as my developer desktop, which is what I'm actually using to do this demonstration. In terms of common features, all of these all do the same kind of thing under the hood to some degree. Fully automatic updates, automating the download, to whatever window you want to do, automating the reboot to whatever time you want to do. The OS is never updated at all during runtime, so it requires a reboot to move from one state to another. But that means it's always moving from one known state to another known state. It was working here. If it's not working there, then we know to throw that away. It's designed with this mindset of doing just one job. Yes, technically, it's still SLES in many respects. You could pile on a whole bunch of other services, but then you're kind of running into, stretching the concept. It works better as having these instances, just doing one thing to monitor, one thing to check, did it work? One thing to roll back if it all goes wrong, which also keeps the footprint nice and low for whatever hardware or cloud or edge that you're putting it on, and makes it even easier for automation and orchestration. So all this is powered by transactional update. You've probably seen talks about this before, so I'm not going into huge details about how transactional update works. The quickest summary would be, if you're familiar with how BTRFS snapshotting works on traditional SLE, where you do an update and it takes a snapshot before the update and takes a snapshot afterwards. Transactional update basically takes that concept and flips it around backwards. So it doesn't touch the running system, that's the whole point, but it makes a snapshot for you to move into the future. So it takes a snapshot and then goes and puts all the changes into that target snapshot afterwards. That means we can make the entire process entirely atomic. All the package changes all go into that new future snapshot. Everything gets checked. Did every package run properly? Did every script run properly? Was there no crazy errors? Of course, because this is happening in a separate BTRFS snapshot, it's not touching your running system at all. Your system's read-only, it couldn't touch it even if it wanted to. And then that snapshot, once it's had its sanity checking, gets marked as the next boot target. So you're then moving entirely to the new system, or if it didn't work right, we throw the snapshot away. It never happened. Doesn't even bother keeping the blocks on disk because there was no point. This, by default, is fully automated. You can turn it off if you want and run it manually, but the standard micro or Aeon installation would be taking place daily with a kind of, we normally pick midnight as when the download is happening. But of course, your system isn't rebooting, so this really is kind of academic. It can happen whenever the heck you want. So it can also happen within 2 hours of the latest boot if your system happened to be off at that time. And then once the download has happened and the update has happened and everything is good and clean and happy, it provides some notification to another part of the stack, either the user in the case of a desktop, Reboot Manager in the case of traditional SLE Micro, which I'll talk about later, or on a Kubernetes cluster, something like Cured on your Kubernetes cluster, your Kubernetes reboot daemon, to basically inform whatever system is controlling it for rebooting, I'm ready for a reboot. So like in the Kubernetes context, your Kubernetes cluster then decides to reboot the node, which also means the Kubernetes cluster can drain the node and bring it back in cleanly and handle all of that fun stuff. If you're not talking about Kubernetes though, and just sort of standalone SUSE Linux Enterprise Micro, then we have Reboot Manager. Super simple tool. Basically, you put in a maintenance window, it's going to reboot in that maintenance window if there's a reboot waiting for it, or if there's a patch waiting for it. That's it. Of course, you turn this off and you can make the reboots manual. That's perfectly fine as well. But this, yeah, just nice, simple, does the job. In addition to all the checks that happen at the point of package installation in transactional update, we have Health Checker. This checks for errors on the boot to make sure, yes, everything installed fine, but does it actually work? The default basic behavior is to check for a whole bunch of services, and you can just add to those services of, what systemd service do you expect to start? If it doesn't start, well, that snapshot must be bad and it rolls back. But this entire thing is modular. You can actually add whatever shell scripting or other tooling that you want to do whatever other detailed checks of, is this service actually running the way it should be running? And any time that those checks fail, it blames the fact it was updated as the problem and rolls the thing back. So you can always kind of guarantee your service is running. You may be out of date a little bit, but your service is running. It also has a fun sort of sysadmin AI emulation of if the system actually has booted perfectly fine, and it did work perfectly fine the first boot, and it hasn't had an update or anything, but the second boot of the same state is suddenly misbehaving, some service doesn't quite start. It tries to act like a sysadmin. It's like, it must work kind of okay, so it just restarts the service a few times. And then if it doesn't work, it reboots, and then if it doesn't work, then it declares itself into an unknown state. So, if you do have slightly flaky services that misbehave, it does its best to act like a human being would to keep the system running until it knows it's really kind of broken. Talking about all of this, kind of encouraging not messing with the base system, so thinking about, running everything as a container or, some VM on top. But there may be times or use cases where actually modifying the base OS makes sense. For example, again, like sort of thinking on the edge, you may just have some RPM of one little service you want to put on there. So on all of our transactional systems, it's a simple case of running transactional update pkg in. Transactional update pkg is basically a wrapper for Zipper. So, it's the same commands you would use in Zipper, the same flags you would use in Zipper. You add repositories in Zipper just like you normally would. You can add packages, you can remove packages. You can also run entirely complicated scripts. So if you have, weird tooling that's all shell scripting or whatever, that's fine. You just run that command in a transactional update. And then all these cases, what they go and do is create that BTFS snapshot for the future state of the system, redirect all of the tooling into there, and away you go. These don't actually necessarily need to be one-shots. So the examples I've given here, it's going to make one pristine snapshot that includes one package installation, and then a second pristine snapshot that will not include the package installation, but will do a remove. But you can actually daisy chain multiple transactional update commands into the same snapshot for the future. You just use the minus continue flag, which I just realized I didn't put on the slide. But of course, messing with the base system means you're running something that isn't exactly what we tested, so there is always the chance of putting something on your system we can't support. then if it does reboot, and it is, you think, yeah, it's passed health checker, everything looks like it was fine, but it isn't actually fine, something is horrifically wrong, a rollback is a simple case of transactional update rollback last. This basically does the same as snapper rollback, but also does a little bit of extra tinkering with the configuration in etc, because we also keep the configuration in perfect synchronization with all those snapshots. And we also handle the fact that the configuration might be something we've modified from an RPM package, and might be something you've modified as a sysadmin, because etc is something that you can read write to, so we have to handle all the possible variations of when did this thing change. And transactional update keeps track of all of that, and then make sure the rollback goes back to exactly the state that it was when it took the snapshot. And you can, of course, use snapper list to list a bunch of snapshots, and if you want, you can roll back to a very particular one in the past. So like I mentioned in passing already, all this immutable Linux stuff typically works best when your services are somewhat abstracted from the base OS. Something like containers, something like VMs, something like Flatpak applications for the desktop. It also means you have the flexibility of, you can control the lifecycle of your container to be exactly what you want, when you want. You'll decide when you push a new container to your registry, and we can just decide when to push our updates to SLE and the SLE micro. It does kind of give that nice separation of responsibilities, which is great. And yeah, it's just the best way of working, really, to be honest, in my view now. And so, yeah, myself, I have now been using this immutable Linux stuff in my daily life since September 2018, when I got rid of my last Leap server and I made it a microOS server. Which is kind of impressive, actually, because I only realized after I wrote this slide, we didn't release microOS until 2019. So, yeah, I actually had that machine running when it was in a really prototypical stage, and it's still running now, and I probably haven't touched it this year. It just sits there, it patches itself, it reboots itself. I'm also doing some consulting for some of our customers now. More and more I'm seeing they're moving in this direction as well, taking SLE micro, putting it in everything from, a traditional data center to, cramming weird little devices in boats in their, and other weird and wonderful places, and then, not updating it for 6 months because it's in the middle of the Atlantic. And now I decided, I love this on my servers, I want this on my desktop. So I've built myself an entirely fresh operating system, OpenSUSE Aeon. It's running basically a tumbleweed code base with GNOME. Everything's automatic, everything's a Flatpak. I never touch an RPM, and if you're interested in seeing that, there's the URL for RC2, because I released that last week. Cool, okay then, let's go get on the bus. I'll see you all at the party. Thanks.